In this video, we are going to review the properties of ionic compounds and then talk about metallic bonds. So ionic compounds, remember, an ionic compound is between a metal and a nonmetal, and when they come together, we call them salts. They have a very strong crystal structure and an extremely high melting point, and they can conduct electricity when they have either melted or when they have dissolved in water, and then we call them an electrolyte. Okay, so let's talk a little bit about metals and how metallic bonds work. Metallic bonds are between two different metals on the periodic table. Okay, they're how metals hold together as a solid. Now, metals hold on to their valence electrons very weakly. We already learned that in terms of ionic bonds because we know that metals tend to give up their electrons. So they're not holding very tightly on to those valence or outer shell electrons. Okay, so a solid metal we say is almost like it's a bunch of positive ions and there is a sea of electrons. Imagine sort of all these outer shell electrons and all these metal atoms that are sort of together when you see a solid metal, and all of those electrons can sort of flow around, okay, which gives metals a lot of their properties. Okay, so electrons can move freely through the solid of a metal, okay, which allows them to conduct electricity. So electricity is really just the movement of electrons from one place to another, or the movement of charge from one place to another. So since metals don't hold on to those valence electrons very well, they can kind of flow back and forth within the metal. Now, remember that metals are malleables, which means they can be hammered into a shape, or they're bendable, okay? And they're also ductile, which means they can be pulled into wires. This is because of the mobility or the ability of the valence electrons to move. Okay, and we'll look at some images here. So here we see ductility, okay? So this is a die. If you take metals, you may have learned about this. But essentially what this is you put a metal rod through it, and you can create a wire of a different size, okay? So we are basically shove the metal through this opening, and we can create some wire of a certain diameter, okay? The reason is because the electrons in the atoms can kind of smush because we can move them. There's that sort of bendability. We can push those electrons in closer to each other or past one another. Okay, now malleability, if we look here, malleability means you can be hammered into a certain shape. So if we hammer an atom, okay, or if we hammer a metal, because those electrons can kind of slide past one another, it can change its form. As opposed to an ionic bond, which is a crystal structure, that when we hammer it actually will repel part of the compound and it will break off, which is why ionic compounds are brittle. Okay, well, let's look at this again, right? So let's say this is a metal, right, and we have these electrons that are free to sort of slide past each other. The little yellow ones are electrons. If I apply a force, then you can see how the metal can just shift and bend and form into a new shape. And that's because the electrons are mobile. They can move. Now, if we were to look at an ionic compound or ionic solids, which are brittle and can break, now if I apply a force, remember here, this is the crystal structure of the ionic compound, so there's positive and negatives next to each other because they attract one another. But if I apply a force, then what happens is now the positively charged proton of one is next to the proton of the other, and then the electrons are next to each other, so they actually repel them, and that's why it cracks like a crystal. Okay, now the last thing I want to mention about metals are alloys. So we learned about this in the first unit. Alloys are mixtures of two or more metals, okay? And we did the alchemy lab, right? So we made brass because we made an alloy of copper and zinc. So we put zinc on the surface of the copper and then we melted it together. It looked gold, okay? It was actually a brass. Another common alloy is bronze. Bronze is actually a combination of copper and tin. So what is the purpose of an alloy? So typically when we mix two metals together, they have properties that are superior to the pure elements. They might be stronger, they might be more durable. Sterling silver is a good example. So sterling silver is mostly silver with a little bit of copper in it. Now, silver is a really, really soft metal. So if you had a ring that was made of like pure silver, if you bumped it on things, you would dent it, okay, and it wouldn't look pretty anymore, right? So by mixing a little bit of copper in with the silver, we make it harder and more durable for, jewelry, but also like silverware and stuff like that, tableware. Steel is also a very important alloy, okay? And again, steel is extremely strong. So by creating the steel metal alloy, we can use it for building and things. Because obviously, if you build a building and you have the foundation is made out of steel, it's a lot less likely to collapse because it is stronger than its parts. Okay, it's resistant to corrosion. Okay, it's hard. It's more tough. It also can be cheaper cost. So those are reasons why we use alloys and what their purpose is.